Hello there, my name is Nev and I am one of the core developers here at Hush Engine. So Hush is a game engine that was built in C++ and uses C# scripting. We all know that this is fairly common, so what makes Hush Engine different is the fact that we use .NET 8's ahead of time compilation feature. This allows C# code to be directly compiled into machine code for the specific platform that you're using. So this makes it very efficient, which is great because we want your gameplay code to be really fast, really efficient, so you can focus on making the games fun, not have to worry about any performance optimization techniques that you might want to implement. We do that for you. You just make your games and you make them fun. Okay, excellent. So right now I'm just gonna show you what our state is. So this whole thing was developed for Backdrop build. It was developed a little bit before Backdrop build 3, but we got it into Backdrop build 3 and 4. And so far what we have is a Vulkan renderer. This is already implemented. That has also Dear I Am GUI, as you can clearly tell here. And the Vulkan renderer is actually working here on the background. This is just an empty scene. So we decided to just put a panel in there to just kind of demonstrate what the scene would be once we get asset loading into the picture. But essentially, if you also want to look at it like this, that is certainly possible. This is how the engine would look once you load stuff into the scene. Anyways, so besides this layout, as you can clearly tell, is a fairly simple and standard layout for any engine. You got your hierarchy here, your play button, you got your project content panel. We got some file dialogues over here with settings and just a tiny button to redirect you to our webpage, just so you can know what's up and what we are doing and currently developing at that stage. Okay, over on the right side, we're gonna focus on here for the majority of the demo. This is our demo debug options. So right now what we have implemented, as I said, is a Vulkan renderer. We also have an input system complete with an input API that you can call from C#. So if we go right now, and I get this is a bit technical, but if we go right now to our input manager, as you can see, it is a complete API that is already that has been set and it's ready to be called from C# for scripting purposes. And so we're gonna demonstrate the input system right now. As we can already tell, I just brought up the console, but we are already kind of like seeing C# and C++ interact here. This is information that's gathered from C++ from C# entirely, and this is the runtime version of .NET that we're using. So that's clearly .NET 8, which, as I said, uses ahead of time compilation. All right, so let's go first with mouse input. Of course, we have mouse input enabled, and once we do that, it logs our operations of the mouse here in the console. We have mouse position and mouse acceleration, so if I move very slowly, you can see the acceleration is just fluctuating between 1 and 0 on the X and Y axis, but if I move quickly, it of course picks that up fairly easily. This also supports button presses on the mouse, so that's left click. It does also tell you the state. Left click, press release. Right click, press release. And the middle button, press release. Awesome, perfect. So let's get rid of these logs and move on to keyboard input, which is also fairly straightforward, just your keyboard. I'm gonna type some information here, and you can already tell that we support the same system of press release, and every key is perfectly mapped to the keyboard. So we have the numbers over here at the top, and then we have the keypad also mapped here for different special keys as well, like the function keys, F2, F5. They're all they're all mapped. Awesome, perfect. And now let's get to the interesting part. This is the C# scripting side of the engine. This is arguably one of the most important things to get right when making an engine. And so over here, we're gonna go through a few examples. So here I have a very simple C# project that I've made. It just contains a class with a few functions. As you can clearly tell, this function right here, get.NET version, is what got called at the beginning of our runtime. So that is already good news that C# scripting is working. But we're gonna call the same name function, for example. And the same name function can be called over here through our GUI that's already in C++. And so my name is Nef, so I'm just gonna go, So I'm just gonna go with Nef over here. Let's bring out the console and greet me from C#. And perfect, hello there, Nef. It's very important that we take into consideration that this is also handling parameters, and not only any parameters, but strings, pointers. So if we can handle strings, we can handle any complex data type, basically. Okay, perfect. And so yeah, this just handles every input that we put in here. We can greet ourselves. We can even say, hello there, backdrop build. And yeah, there we go. It's there for backdrop build. Okay, perfect. Let's clear that out. And let's continue with another demonstration of scripting. We all know that concatenating a string, that's not really that much processing. We can also calculate hashes, for example, and this is very important to mention, because now we're not only taking parameters as input, but we're also returning data. So the previous one was a void function. This was all done inside of C#, which is perfectly memory safe. So there's not really that much going on the C++ side once the call to execute this function has been passed on to the runtime of C#. But here for the calculate hash function, this actually returns an MD5 hash for whatever input we put in there. So this is returned to C++ and we actually manipulate it in C++. And so we can see that over here. If we get our hash of any string that we can think of, it will be displayed not in the console but on IMGUI. So for example, I'm going to do here ABC, hash your input, and there we go. Our input from C# from C++ is ABC, and from C# is this hash over here. And so let's do again my name. Perfect, it hashes it correctly. And I'm gonna do again backdrop build. Backdrop build. Perfect, it hashes that appropriately. And so yeah, there we go. Hashes in C++ and C#. And again, this is really important because we are handling data from C++ to C# back to C++. And now let's go to our API calls. So we have here a method called API test, which just basically goes to a sample API that's on the web. And as you can clearly tell, this is a valid URL for an API. So over here, let me just do that. Okay, perfect. As you can see, it goes hello from string boot, and if I pass in here a number, it will return a JSON containing all the information about just some standard objects for like purchases, like from a store. Okay, perfect. So let's see how that works on the Hush engine. So as you can see here, the call to the function is very straightforward. What we can do over on the Hush engine is we can do dynamic calls, getting the references to these function pointers through strings, which is very powerful because this allows us to just invoke any method from C# at any time, even if we don't have it registered within our scripting module. So this method right here called object API, that's not registered to our scripting module. So here I'm gonna select a class, which in this case is the API test class. And I'm gonna select a method from that class, which is call object API. Call object API. And let's bring out the console because this happens in C#. Oh, sorry about that. We have not handled resizing yet, so that's the reason why you saw that there. No worries. So again, our test class from C# was called API test. And our method is call object API and script away. And there we go. It gets the response from the server. It says it's okay. And then we get an actual JSON file, which is coming entirely from the web, which is kind of cool. All right, and to demonstrate that that's not static, as you can see, it's an Apple MacBook Pro. Let's call it again, and now we get an Apple Watch Series 8. Let's call it again, Apple MacBook Pro again, and iPhone 12 mini, iPad mini 5th gen. Okay, perfect. So yeah, the API calls are working properly, which this enables, of course, the engine and the games within the engine to be connected to the internet in many ways. All right, perfect. And that is basically what we have for the Hush engine at the moment. We know it's in very, very early stages of development, but we are really excited to just keep on working on this, and we already have many of the main modules developed or designed so that we can just like integrate them properly into the engine and just make the best out of it. And so yeah, it was very cool to work on Backdrop Build v4, and yeah, hope to hear from you soon.